acid cycle. We have to remember that for every cycle of the citric acid cycle, it's only one pyruvate, but for every one glucose, there's two pyruvates. So we have to remember cycle twice, so that's why I always write times 2. So we're coming out of the transition stage. So once you come out of the transition stage, you have your pyruvate, which I always like to write just like this, and you drop it down to acetyl CoA. And this is basically just what carries the carbons down into the citric acid cycle, and they're gonna bind with 2, 3, 4. So this is oxaloacetate. The way I remember this, am I explaining it in the funny way or?
Funny way, yeah.
Funny way?
Go ahead.
All right, so these girls are all going out on a date with this guy, right? They come to find out that this guy has 4 housewives, and they're not, one of them is just not really that happy about it. So through pyruvate to acetyl CoA, it burns, it's so pissed, it burns off as carbon dioxide. So it burns off gas. So these girls are like, I can handle this, I got this. So they come down, they're like ready to go. So I think as OXA acetate. This is like their name. This is their maiden name. And in order for these guys to come together, they have to change their maiden name to the husband's name, whatever that is. So in order for this to happen, they have what's called citrate synthase. I think that's how you spell it. And that basically is what allows this to happen. So this is like the judge. And the judge is like, and here, oxaloacetate plus acetyl is now citrate. So it is citrate now. And these ladies are not happy about that, let me tell you. So 1, 2, 3, 4, 5, 6. Again, drawing out the 6 just so that you remember it. And so we're going to go down, and right away you actually take NAD plus and you reduce it down to NADH. And I always put 2 little dots to remember that there's 2 electrons that come on that. So that's the first yield of energy that you use in the citric acid cycle. And so these ladies have it out to get rid of these people. So somehow they do it, and this girl gets really upset, and so she burns off as carbon dioxide. So that's the second carbon dioxide. There's 1, there's 2. They continue through the citric acid cycle, and there's 5 carbon chain. 1, 2, 3, 4, 5, right? Somehow, I don't know how, but these ladies make it happen where she gets really upset, so she burns off as CO2. So she's really upset. Then we're going to have another utilization of NAD that reduces. Reduces means adding hydrogens. NADH, again adding your little 2s. So then now there are 4 carbon chain. I'm going to keep writing 4 carbon chains just so you know that they kind of evolve into different types of sugar. But down here you go GDP plus an inorganic phosphate yields to GTP. Remembering that this is a nucleotide, and it's basically the same thing as doing ADP plus an inorganic phosphate yields to ATP. Adenosine triphosphate, guanidine triphosphate. So now we have our carbons, and it kind of evolves into different, like maltate, sucrate, or, I'm not exactly sure the specific names, but somewhere up here, you get your first FAD yields to FADH2, just like that. So that is the reduced form of FAD plus. So that's oxidized, reduced. So it's giving away its hydrogens. So then up here somewhere, you're going to have the final NAD plus yields to NADH, again, the reduced version. And then it comes back to its maiden name, oxaloacetate. So the housewives got what they wanted. So altogether, yielding yields, and I just think of yields as energy. So we count it 1, 2, 3 NADHs. They're little dots. And then we count 1 FADH, 2, and then we have 1 ATP. But remember, we times it by 2, and now we have 6 NADH, 2 FADH2s, and 2 ATPs. That is what you yield. Product, sorry, I'm writing this all crazy, is going to be how many? 1, 2 CO2s times that by 2, and you get 4 CO2s. It is not by accident that the final reaction is glucose plus 6 O2 yields 6 CO2. So you have 1 here, times it by 2, so you get 2 CO2s here. Add to this, and you get that. That's where that comes from. Yay!
Yay!